Everything's fine. Before I start, I would like to take a photo with you. So, big smile. Thanks a lot. Okay. Hello, everyone. Thank you very much for coming up here, for being here, for choosing my presentation. And I really enjoy this kind of events when we are fully focused on one particular topic, microservices in this case. And I'm really glad that I can be a part of it. And I really appreciate it that you are here, that you came to Voxxed Days Microservices. And before we start the presentation, I'd like to tell you a few words about myself. My name is Bartłomiej Słota. Maybe it's hard to pronounce for you, but you can simply call me Bart if you like. I am a software engineer. I am a speaker. I also run a blog. I came here from Warsaw, Poland, and I currently work for Agile Tech, which is a technology center of financial giant Hargreaves Lansdowne from Bristol, UK, which is the largest financial service company in the United Kingdom. And what we are doing up there in Warsaw is developing software with the latest techniques, with the latest technologies to make Hargreaves Lansdowne more competitive, to serve services of higher quality. And regarding myself, the main areas of my interests are object-oriented programming, software craftsmanship, microservices, and all the stuff somewhere around software architecture. I also like to work very closely with the business people. I am an enthusiast of event storming. I facilitate this kind of sessions as well. And here on the slide, you can find some of my contact information. You can follow me on Twitter. You can visit my blog page. All code examples that you will find there and during today's talk, you will find on my GitHub account. Don't hesitate to write me an email if you have any questions or remarks regarding my talk or my articles. And if you're interested in what I'm doing professionally, just visit my LinkedIn profile. Okay, the topic of today's talk is dynamic configuration management in microservice architecture with Spring Cloud. The title is a bit long, but it tells almost everything about what you'll find here today. And during this presentation, I will give you a hands-on example of a simple microservice architecture, which we'll analyze and improve in the field of configuration management, so that we can finally reconfigure our apps dynamically without the need of rebooting or rebuilding our apps. And all those things we will do with the help of the almighty Spring Cloud. And during this presentation, I will introduce you to the topic of configuration management. We will discuss some issues that we face in distributed environments, and we will try to solve those issues with the help of Spring Cloud. You will see how to set up a config server, how to integrate with it from the client's perspective, and finally, how to make use of Apache Kafka in order to dynamically reconfigure our applications. Just a quick question to you. How many of you use Spring Boot in production in your day-to-day life? Wow, fantastic. Good. Let's start with answering the question, why should we care about configuration at all? And, well, in the scary world of monolithic applications, we succeeded in working out numerous design patterns, some good practices. But when we move towards distributed environments, we should apply those patterns very carefully. Especially today when there's hype around microservices and all software developers around the world would love to create their next greenfield project in microservice architecture. But there's usually something missing in between, because microservices are not just an ordinary distributed environment. They are something more. Microservices should empower us to respond to changing requirements lightning fast. We need to scale, redeploy, and reconfigure our applications much, much quicker than ever before. And regarding the patterns, it should be obvious today to keep our configuration outside the code, so that we can very easily locate it without the struggle to find the proper line in code to be modified. But there's also one more thing that stays behind externalization. Externalized configuration should enable us to run our application on whatever environment we like. Build once, run anywhere. These are the config files that should enable us to run our application wherever we like, to adjust our application to a given environment. Another thing is that we usually keep our configuration files bounded with our deployment package. They're usually part of a jar archive, right? Of course, we may keep some of our config files on the server outside of the jar file, but then we lose trace. Usually, we lose trace about what's going on up there. I will tell you a few words about traceability in a second. In this case, when we have our configuration bounded with deployment package, in case of any changes within the configuration, we still need to rebuild and redeploy our application, and it can be very frustrating when the configuration changes more frequently than the code itself. Another thing regarding microservices is scalability. We scale services for numerous purposes. We scale because we want to stay resilient. We scale because we want to serve a bigger load, or whatever the reason for scalability is. When we update the configuration of our service, we need to update it in every instance of a running service. So if this process is not fully automated, it can be a really, really tough task to do. Another thing is security. It might also be the case that we developers have restricted access to credentials to production databases, some external services, and I can tell you a story from one of the companies that I worked for, and I think that many of you might have experienced that as well. We were developing some monolithic monster, and when we were about to deploy it on every of 12 available production servers, it required client administrator to take the properties files on every of these 12 machines, update the properties just before running the application. This was the way that we provided security, because we developers have no access to those production credentials or production properties. But it was our role to provide a specially formatted Excel spreadsheet and write what properties in what way should be set. This was the security. But at the same time, we had no idea of who said what, when, and where. And in case of any errors in production, it was extremely difficult to locate the real problem. So you can see how confusing and complicated the configuration management in distributed environments might be. Of course, we use properties files, YML, but they just might not be sufficient. Now we'll show you an example using which we will solve all those issues with the help of the Spring Cloud. And what you can see here on the slide is that we have, at the very bottom, we have a couple of business services. The customer manager and product manager that are obviously responsible for managing customers and products. Let's assume that both of these applications are accessible from the outside world only through the gateway application, which is an implementation of the API gateway pattern with the help of Netflix Zool proxy. And with the help of Netflix Zool proxy, we can very easily both route requests to proper services, and at the same time we can manage some common issues like security, for example, make some request filtering, authorization, or whatever else. And on the left, you can see that we have infrastructure services. Currently, there is only one service, which is a service discovery in the form of Eureka server, and all those applications communicate with each other using HTTP protocol. And I took the liberty of starting those applications just before the presentation. And what you can see here is Eureka dashboard. And like you can see, we have 3 applications that are successfully connected to Eureka. We have a customer manager, gateway application, and product manager. And customer manager running on port 8085, gateway on port 8080, product manager port 8086. All applications are in the app state. We have 1 instance per each. And yeah, so you can see that they are working. And to be 100% sure, let's send a couple of requests. We'll start with sending a curl localhost 8080. I'll send all requests to port 8080 because this is the place where my gateway application is located. And we agreed that we will communicate with services through the gateway. Let's ask for all products. We have some 3 simple products: web page, graphics, SEO. And let's ask for customers as well. Here we have customers, and we have 2 available customers, Bruce Dickinson and Stevie Harris from Iron Maiden. Are there any Iron Maiden fans in the room? Yeah, that's great. Regarding customer management, regarding customer manager, we can distinguish premium customers. I introduced some kind of customer segmentation. In order to get premium customers, we just add a query parameter here, and currently we have only 1 premium customer here, Stevie Harris, with the email stevie@yahoo.com. Premium customers are those customers whose email address ends with fully configurable suffix, and with this suffix we'll play during today's talk. Okay, you can see that this application works. Let's have a look what sits under the hood. What I have here in my IDE is a multi-module Maven project I have service discovery, gateway application, product manager, and customer manager. And because the configuration management in every of these application would be pretty much the same, I will focus just on one of them, on customer manager. And what I'll do now is I'll show you the pom.xml file is a simple Spring Boot application. I have a Spring Boot Starter parent. I have dependencies like Spring Boot Starter Web, Actuator, Data JPA, Netflix Eureka client in order to register my application in Eureka. I have Sleuth, H2 database, and because we are talking about configuration, let's have a look at the application YML file. Apart from some standard properties like application name, server port, Eureka client configuration, I have this premium email suffix property that I already mentioned. And as you could see when I was sending the curl request, it is currently equal to yahoo.com. And the place where I'm using this property is a class called customer service that is annotated with service and refresh scope annotation. I will get back to the refresh scope annotation in a second. And what I'm doing with it is that I am injecting it through constructor injection over here, and I'm using it in order to filter all clients looking at their email addresses and checking if they end with this particular premium email suffix. Okay, now we know that these applications work, you know what's sitting under the hood. Let's try to solve all those mentioned issues with the Spring Cloud. Now, the Spring Cloud comes up with a Spring Cloud config module, which is a tool that provides both server-side and client-side support for managing configuration in distributed environments in a centralized manner. And let's start with a config server, maybe. What it really is. Well, the config server can be treated as remote property source, and it can be backed by numerous storage providers like Git, for example, which is the default setting, but we may use SVN or some distributed file system as well. You can even have more than one storage at the same time, and it's possible to keep configuration of different microservices in different places. You can have configuration for one microservice in the Git, second one in the SVN, the third one in whatever place you like. Moreover, with Git, let's stick to Git as this is a default and very reasonable setting. Sticking to the Git, we can very easily manage configuration files for any application and any environment. So the first thing that we solve is that we have externalized configuration. With the help of Spring profiles, we can provide environment independence of our application. We keep our configuration outside of our deployment package. And with Git, we gain access control, because in almost every Git provider, like GitHub, for example, or Bitbucket, we can very easily define some groups, decide which users can access which branches, which files, etc. So we can very easily, for example, restrict access to some production properties. At the same time, Git is append-only changelog, which means that we have full history of what's going on the server with our configuration. So we also solve the security and the traceability issues at the same time. So you can see that using a config server with Git as a backing service, we solve almost every issue apart from scalability, which is the one that we will solve in a couple of minutes as well. Okay. This is how the setup of our system will look like in a second. What we have here is that now our infrastructure services are enhanced with additional service, which is called a config server, that connects to a GitHub, where we have repository with our config files, and the process of the configuration loading will look like this. Whenever the business application is booting up, is starting, it will connect to the config server in order to fetch the configuration that is stored in GitHub. Okay, let's move now to the IDE, and let's try to make our infrastructure look exactly like this. So what I'll do now is that I will create another Maven module with the help of Spring Initializer, and the ultimate version of IntelliJ IDE also have some kind of plugin that helps us with this. So I have Spring Initializer here. What I'll do, I'll set a group name com bslota. Let's call the artifact CS from the config server, config server. Okay. And because we want to create a config server, I will check the config server dependency here. Let's also add an actuator. And because I want my server to be consistent with already existing infrastructure, I will also add the Eureka discovery dependency. And My idea will be indexing files right now, but in the meantime, I will show you the pom.xml file. So you can see that the config server is a standard Spring Boot application, and the core part of it is dependency called Spring Cloud Config Server. As most of you are Spring Boot developers, or you're using Spring Boot in your day-to-day work, you probably are already used to using the annotation starting with the word enable in order to tell our application, to tell Spring that we want to enable some functionality. And in this case, we need to use enable config server annotation. And now what we need to do is to configure the config server somehow. What do we need to set up here is maybe let's start with some simple properties like Spring application name. It's very vital to set Spring application name if we are using service discovery. In our case, it will be config-server, and let's run it on server port 8888, which is a conventional setting which you will find in almost every tutorial that you will find in the internet. And now what we need to do is that because we agreed that we will keep our configuration in Git, we need to tell our config server where this Git repository is located. And in order to do so, what we need to do is to set this property, Spring Cloud config server Git URI. And I already prepared such repository. It is located in my GitHub account, https github.com/bslota/config repository.git. And of course, Spring Cloud config gives us a lot of options of configurations, like you can see it here. I will only show you a few of them which I used myself. We'll start with clone start property, which is by default equal to false. When I set it to true, as the name of the property implies, it tells our application to load the configuration from Git eagerly during the server startup. Of course, this will increase the booting time of our config server, but at the same time, we will not increase the booting time of our business services, because now the configuration will be cached and we will be able to serve it right away whenever the business application will be starting up. Another thing that I would like to set here is search paths. Search paths property tells our application where exactly in this repository, in this config repository.git, are my files located. And what I have there, which you will see in a second, that I have one common directory called config, and there I have one folder per each application. So I'll use a placeholder, and I will tell you about placeholders in a second. And because I want my solution to be consistent with already existing one, I'll just copy the configuration of my Eureka client to be sure that everything works as expected in terms of service discovery. And the concept that stays behind config server is remote environment repository. As you are Spring developers, you should already know what environment in Spring Framework is. But what is this repository? Let's open the class called environment repository. Repository.java. Where is it? It's here. And what you can see it here is a very simple interface that tells us almost everything about how things are organized within the config server and the backing service. And we have one simple method, which signature tells us a lot. In order to properly identify an environment for our application, what we need to pass to the config server are three things: application, which is the application name; profile, which is the currently active profile; and label, which is an additional parameter resolved by the backing service, and in the case of Git, it can be a branch name or a tag name. Okay, so let's put it into practice and let's run our application. Let's run the config server. Because I'm doing live coding, almost everything can fail. So I need to have some water. It seems to be working fine. Okay. Yeah, to be sure that everything works, I will just refresh the Eureka dashboard. What you can see here is that we have a config server successfully registered in Eureka and is in the upstate, and we have only one instance running. But remember, if you run the config server on production, always scale it up for resilience, because this is a central part of your infrastructure, and all your business services will depend upon that. Okay, so you can see how easy it is to set up a config server. Now, what we need to do is to tell you a few words about these three things: application, profile, and label. Like you can see, when we were configuring our config server, I used the placeholder. These three things, application, label, and profile, can be used here within configuration. And what we have here is that we have one common repository and application-dependent folders. But if we use application or profile placeholders somewhere here in the URI or in the search paths, we can very easily choose one repo per profile strategy or one repo per application strategy. It is up to you to choose the strategy that suits you best. But these placeholders, these parameters, have one more role, because they define the API that our clients will use in order to fetch the configuration. And what you can see here on the slide is that we have plenty of options to download the configuration of our given app in a given profile and with a given label. The big advantage of Spring Cloud Config Server is that it is an HTTP endpoint, so your microservices does not necessarily need to be a Spring Boot applications. Of course, it is the most convenient options to use just Spring Cloud libraries, but if you have some Scala services or whatever, you can just hit the endpoint and get the configuration for your application. Okay, so you can see that the config server is running. Now let's try to integrate with it. And what I'll do is that I will get back to my customer manager, and what I need to do is to add this particular dependency, Spring Cloud Starter Config. Thanks to the Spring Cloud Starter Config, my application will know that during the startup, it will try to download the configuration from remote property source. And before I tell you what you need to do in order to configure the client, you need to know what is a Bootstrap context. The Bootstrap context in Spring Cloud applications is a parent for main application context, and it is used for the purpose of downloading and decrypting, if needed, of course, properties from external sources. And it is by default defined in the Bootstrap YML file. This file is currently empty, but don't worry, we'll fill it up in a second. And what you should put in this file are two things. First of all, you need to tell our application where exactly the config server is located. And the second thing is how to identify the environment within the config server. Do you remember application profile and label parameters? This is exactly what we need to set up here. Okay, so let's start with it. Spring Cloud config name, profile, and label. And thanks to creators of Spring Cloud config, we have a very reasonable defaults here. First of all, Spring Cloud config name is by default equal to Spring application name. So what we need to set here is Spring application name, which is in our case equal to customer manager. And because the Bootstrap is parent for application context, we no longer need this property being set here in the application YML. So we also don't need the Spring Cloud config name property being defined. Spring Cloud config profile property is currently by default equal to comma separate the list of currently active profiles. So we also no longer need this property. And the label is evaluated on the server side, and in case of Git is equal to master, to our master branch. But for the purpose of this presentation, I created a branch called Paris, or maybe in French I should pronounce it Paris, all right, Paris. So we have a branch Paris. And the last thing that we need to set up here, as I already mentioned, is that we need to tell our application how to find the config server. And here we have two possible strategies. The first strategy is called config first bootstrap, and it assumes that we provide the URI explicitly here in the configuration, and it will look like this: localhost 8888, which is also a default setting. But this strategy has its drawback because we cannot benefit from our application being registered within Eureka, within service discovery. To overcome that, we can choose another strategy which is called discovery first bootstrap. In the second strategy, we will find the config server using the service name. So in order to do so, we need to enable discovery with discovery enabled property set to true. And of course, we also need to provide a service ID in order to properly identify the config server. And in our case, this application is called config-server. And of course, this strategy also has its drawback because now we need to make an extra network round trip before we start the application in order to get the service registry to find out what is the URI of the config server. Okay, so let's now rerun our applications, or just one application. Customer Manager, let's rerun it. I hope it will work. I'll have some water. In the meantime, I will show you our repository that we have in Git. What you can see here is that we have the config directory and application dependent folders, and here you'll find application YML file. And what you can see here is that I have premium image suffix property being set to gmail.com, which differs from the one that we have in our local application YML file. And now I expect that if I ask for all premium customers, now the only premium customers will be those with email ending with gmail.com. Why is that? Because the configuration that is stored in the config server takes precedence over the local files. Okay, so before I prove to you that my premium customers are now the ones that have email addresses ending with gmail.com, I want to show you two things in our logs. First of all, here we have a confirmation that we are fetching config from the config server running on port 8888. And you can also see that we have located an environment for a service called Customer Manager for default profile. I didn't set any profile, so that's fine, with label Paris. And what you can see here also is a version. And I was asked a couple of times when I was doing this presentation before, how can we know which commit ID are we currently using? Which version of my configuration is currently used by my application? This is it. This is this version. This is the commit ID from our Git repository. Okay, so let's move to the terminal and let's ask for premium customers one more time. And what you can see here is now the only premium customer is Bruce Dickinson with email ending with gmail.com. Okay, but configuration management is not only about storing the configuration and loading it during the booting time of our application. It is also reloading it during the service runtime. Okay, so here we have a couple of options. The easiest one would be to do it manually, and thanks to the actuator, we have a refresh endpoint that enables us to send a post request and force our application to update its bootstrap context. What does it mean to update the bootstrap context? Well, updating bootstrap context means updating environment from both remote and local property sources, and rebinding all beans declared with annotated with configuration properties annotation, reloading all beans annotated with refresh scope annotation. You could already see that we have one bean annotated with this annotation, and rebinding all log levels. So now, if we make an experiment in a second and update the configuration and send a post request to refresh endpoint of my customer manager service, I expect my customer service class and my customer service bean to be reloaded. And because there I am injecting the property premium image suffix, I expect it to be applied over there. Okay, so let's make this experiment. Let's change this premium image suffix from gmail.com into yahoo.com again. I'll make a comment, git commit. I will push it into my branch Paris, and yeah, it worked. So what I'll do now is that I will send a post request, post localhost 8085 /actuator/refresh. And The bad thing about this is that I need to know where exactly an instance of my service is running, which host, which port. And if my service is scaled up to a couple of instances, I don't even want to think about how I would manage this. So still we have a living problem of scalability. But anyway, let's send this request to my application. And what you get in the response are two things. First of all, we updated client config version because we made another commit and pushed to our branch in the Git. So we updated the version, and at the same time, we also updated the premium email suffix property. To be sure that it worked, let's ask for our premium customers, and now I expect to get Stevie Harris back here. And yeah, but still, it will be frustrating to manage the configuration like this when you need to remember where your services are. So the desired scenario would be that all our services are automatically, asynchronously informed about the need to reload their bootstrap context. And what you can see here is that now our infrastructure is enhanced with the Apache Kafka. But I'll get back to Apache Kafka in a second, but anyway, we need some tool to propagate this management instructions, this configuration updates. And in order to do so, we will use Spring Cloud Bus. And Spring Cloud Bus is a tool that was built to propagate management instructions, and it makes use of both actuator by adding new endpoints to our application, and by utilizing Spring Cloud Stream, by enabling communication with AMQP brokers, by giving the abstraction over AMQP brokers. In our case, I'll be using Apache Kafka, but I need to tell it to you right away. If configuration management is the only reason for you to set up a Kafka cluster, then just don't do it, because it is an overkill to manage a Zookeeper cluster and Kafka cluster to send a couple of messages in a week. Then I would rather go for some lighter solutions like RabbitMQ, for example. But if you already have Apache Kafka in your infrastructure, in your company, you have event-driven architecture, just use it. I'm a big fan of Apache Kafka, so that's why I'm proposing this solution. And I keep it alive most of the time. I have a Zookeeper here, Kafka cluster over here, and I have also some console consumer I'll show you in a second what for. And let's make our infrastructure look like this. We already have Apache Kafka cluster running in my one node cluster running in the background. I will now move to the IDE and try to reconfigure my application so that they are consistent with the diagram that you could already see. Okay, let's start with Customer Manager maybe. The dependency that I need to add in order to answer to and listen to all those management instructions from Apache Kafka is Spring Cloud Starter Bus Kafka. And if we open the pom.xml file of this dependency, you could see that we have a Spring Cloud Bus that I already mentioned, and also we have a Spring Cloud Stream Kafka, Spring Cloud Starter Stream Kafka, in order to give an abstraction over the Kafka broker. And because my Kafka cluster is running on default settings, and those defaults are the same in Spring, so I don't need to set up anything. But anyway, I would like to show you what you need to do if you do it in your day-to-day work in your job. So what you need to set is Spring Cloud Stream Kafka binder brokers. In my case, is localhost 1992. Okay, so let's rerun my application, Customer Manager, and check if it successfully connects to Apache Kafka. It will take a couple of seconds. But there's one vital thing that I would like to show you in the logs again. Yeah, it is starting. Yeah, I see the logs from the Kafka client, and I'll look for a set of words, Spring Cloud Bus. And you can see that Spring Cloud Bus is occurring very often over here. And what is the Spring Cloud Bus? It is the Kafka topic that we will be using in order to propagate all those management instructions to our applications. Okay, so let's now move to the config server and let's make those changes there. Here as well, we need to add a couple of dependencies. I'll make some copy pasting here. I need this one, for example. And Like with the customer manager, what we need to set up here is Spring Cloud starter bus Kafka. This is the first dependency, and the second dependency is Spring Cloud config monitor. And Spring Cloud config monitor gives us something extra. Gives us the new monitor endpoint that accepts post requests with information about which service needs to be reloaded, needs to refresh its configuration. And now we are dealing with the scalability issue, because now what we need to know is where the config server is located. If we shoot a request to the monitor endpoint, we tell our config server, hey, let's reload the configuration for this application that I give you in the payload. Okay, and now what config server will do is generating the messages, proper messages to our broker, Kafka broker in our case, and all interested services will read this message and reload their configuration if needed. Okay, so let's rerun also the config server. It will also take a few seconds, and after that we will try to make an experiment once again to see if it really works, the dynamic configuration really works. Okay, it's successfully connected to Kafka. To be sure, I will just refresh the Eureka dashboard. Everything seems to be fine. Okay, so let's get back to our repository, and let's set premium email suffix to gmail.com once again. Let's make a commit. Let's make a push. And now what we need to do is to send a request to a monitor endpoint. Curl -x post localhost 8888. And like I said, what we need to know now is where is the config server. We no longer need to know where exactly my application is located, how many instances of my application is currently running. We are solving this issue with this simple request. And what you can see here in the data, we are just telling our config server which particular application do we want to restart. Do we want it to reload its configuration? Okay, let's send the request. And what we will get back in the response are the name masks, something like this. You can see that the config server tried to reload configuration for application named customer dots manager or customer dash manager, and we are interested only in the second one. And I also have a Kafka console consumer running and listening to Spring Cloud bus topic. And what you can see here is that we have refresh remote application event that was sent to the Kafka topic. It originates from config server running on port 8888, and the destination service is customer manager, right? And what you can also see is that customer manager responded with acknowledgement, ACK remote application event, and here you have information to what event it responded. Refresh remote application event, and here's the confirmation that it was the customer manager. To be sure that it worked, let's ask again for all premium customers, and now I expect to get Bruce Dickinson as the premium customer, as this here. Okay, what you could see on this presentation is that the configuration management can be very tricky, very confusing, and very complicated. With the help of Spring Cloud and Git as the backing service, we can very easily keep our configuration externalized. With the help of Spring Profiles, we can make our application environment independent. At the same time, we keep our configuration outside of our deployment bundle. We provide security with our Git providers. We provide traceability because Git is append-only changelog. And with the help of Spring Cloud Bus module and Apache Kafka or any other AMQP broker that is supported, we can deal with scalability issue, because now we don't need to care about where and how many instances of our service there are in our infrastructure. But what you need to also know is that software development is about trade-offs, always. Managing configuration in a centralized manner like this is a very good thing, but it has its drawbacks as well, because it complicates continuous integration and continuous deployment processes, because now you have two separate places where you keep your configuration. So it can be tricky a bit. You need to remember that. And what is also very vital is that you need to remember that it's up to you to choose the best strategy about where and how you store the configuration. In our example, we have one single repository with application-dependent folders, but you may choose one repo per profile strategy or one repo per application strategy. It is a very vital choice. And one thing that I didn't mention, and I'll do it now, is that to fully automate this process, what we could do is to set up a webhook in our GitHub repository that would send a post request to our config server to the monitor endpoint whenever anything changes within our configuration. And then we'll have our hands clean, and it will all be done automatically. Okay, that's all from my side. I really appreciated that you came here, that you stayed to the end. Thank you very much for coming up here. I'll be here today for like 3 or 4 hours before I leave for my flight. And thank you very much once again. I'll be more than happy to have a chat with you. Thanks.